In this video, I will demonstrate how to complete exercise 20 from homework 8. In the exercise, we're told that art history professor was studying art from different periods of time, and the ratio of the larger dimension to the smaller dimension of the artworks was compared. And in 37 early works, the average was 1.74 with a standard deviation of 0.11. And with the later works, they were averaged 1.746 with a standard deviation of 0.1064. And we're supposed to figure out if there's a significant difference in the golden ratio calculation. So what we'll do here is we'll go through the hypothesis step examples, or hypothesis test steps. The first step is to identify our hypotheses, or our parameters. And so I'm going to insert symbol here, there, mu. And we have two parameters that we're dealing with here. It's the average golden ratio calculation from early works of art and the golden ratio calculation, the average from the later works. And so I'm going to have to identify two parameters. The first one I'm going to call mu1. Mu1 is the average golden ratio. I'm going to put this in quotes. The average golden ratio calculation from art made in 1900 through 1919. And then mu2 will be the art made in the later period. So 1942, whoops, and this is 1920. I'm going to change this to 2. So there are our parameters. Next, we need to set up our hypotheses. Notice up here that it's just asking if we think that there is a difference. And so you're going to get a clue as to what your hypotheses should be based on the statements in the problem. In this case, it's just asking if there's a difference. And so one of my hypotheses will be that the two averages are different. So the other hypothesis will be that they are the same. To write this mathematically, two things being the same would be that they are equal to one another. So that's going to be my null hypothesis. And then the alternative hypothesis is that they're different from one another. So let's see if I can change this. I need the not equal to symbol. And that's the alternative. The next step is to identify the distribution that you're going to be using. And with everything this week, we're just using the t-distribution. The next step is to get the p-value. To get the p-value, we're going to have to use our calculators. So let's get our calculator out. Oops. And let's see, I want to make sure I can see all of my statistics. Good enough. What I'll do is I'll go over to test, and this is a 2-sample t-test. I'm going to enter stats because the statistics are given to me in this problem. And then I just have to enter the statistics for these two samples. The first sample comes from the early works, and it says that there were 37 early works that averaged 1.74, standard deviation of 0.11. And then the 65 later works averaged 1.746, standard deviation of 0.1064. There were 65 of those. The alternative hypothesis is not equal to. Notice that not equal to here. I want to make it match on my calculator. The data is pooled, or is not pooled, sorry. We're not going to use pooled data for the standard deviations. Finally, just calculate. And you can see the p-value is quite large, 0.7894. This is an unusually large p-value, but it's not incorrect. The reason it's so large is that you'll notice that these original averages, the data, is very close to one another. And when the averages are so close, the p-value is going to be very large. Finally, we have to state our decision. We are going to accept the null hypothesis because p is greater than 0.05. Notice that no alpha value is given, and when no alpha value is given, just use 0.05 or 5%. Finally, the conclusion is that there is not enough evidence to suggest that, and I'm going to copy some of this. There's not enough evidence to suggest that the average Goldman ratio calculation from art made in 1900 through 1919 is different from the average Goldman ratio calculation from the later art.